Question 1. You're going to be using two different equations to do this. You're going to be using the sine rule and the cosine rule. So look, if we start off with the sine rule, sine A over A equals sine B over B, and in turn that equals sine C over C. Now, if you look at this here, there's no A's whatsoever, so the A's can disappear. This is the sine rule. Bring up the B, bring up the C, and what you end up with is C sine B equals B sine C. And that's exactly what we have here. Proven. Okay? So that's number 1. Now, I was also asked to do, I think it was number 5 is the next lowest. Number 5 I was asked to do, was I? Okay. Now, what we got to do next is we're going to write down the sine rule again. Sine A over A equals sine B over B equals sine C over C. Now, what we're going to do is I'm going to multiply this out a little bit. Okay, I'm going to multiply out the left hand side of this equation just to set up. So I'm going to have A sine B minus A sine C. I'm going to have B sine C minus B sine A, and then I'm finally going to have B sine A. I'm going to have C sine A minus C sine B. Now, what's going to happen is I have 3 different combinations of sine rule. I have the blue, which is the first one. Then I'd have green, which is the second one. And then I finally have the third one, don't I, which would be the first and the third one. So I can use the sine rule 3 different combinations. Do you understand that? So look, I'm going to start off with the first combination, okay? The first combination is going to be this one here. And what I'm going to do is go and cross multiply. Okay? And when I cross multiply, what I'm going to get is this. B sine A equals A sine B. So B sine A, which is minus, cancels with A sine B. Okay? You can bring it over to the other side and we can say is A sine B minus B sine A equals 0. What you can now do is an interchange. Do you understand what I mean by interchange? I can say likewise and replace A with, let's replace A with C. And we're going to get C sine B minus C sine B minus B sine C equals 0. Does that affect us in any way? Look for C sine B. C sine B is here. It's the same as B sine C. You can just multiply both of them by minus 1 and switch them around if you want to make sure that it's exactly alike. Okay? And then finally, the last one involves A and C. Means get rid of your B's. Replace all B's with A's. And what we're going to get is A sine C. You stop that please. Equals C sine A. So A sine C minus C sine A. There's A sine C and C sine A. And they cancel out. So you end up with 0 equals 0. That's how you do that one. All sine rule, okay? I'm doing number 7 next. Now, number 7 very much involves a cosine rule. Now, I'm going to write down my first cosine rule. In fact, actually, I'm going to multiply it out a little bit. Because why did I decide to multiply this out? Can anybody tell me? Why would I have a good feeling to multiply it out? It looks like the very ending of all cosine rules. Right, put away the field, please. Okay, so guys, what we're going to have here is this. A squared equals B squared plus C squared minus 2BC cos A. We're going to isolate the 2BC cos A, bring it over to the left, bring the A over to the right. And what we're going to get is this. We're going to get 2BC cos A equals b squared plus c squared minus a squared. Now I'm going to write down in the corner is change a changes to b, and therefore it's going to be 2ac cos b equals a squared plus c squared minus b squared. Okay, and then on the next one I'm going to say that b turns to c. So the equation above, any b's turn to c. So it's going to be 2ab cos c equals a squared plus b squared minus c squared. So does everybody understand that's all three versions of the cosine rule? Now that I have this done, what I gotta do is, there's three answers, A, B and C. Equation A, equation B and equation C, and we're going to add them all together. Okay? So what we're going to get is this. We're going to get b squared plus c squared minus a squared. We're going to get plus a squared plus c squared minus b squared. And finally we're going to get a squared plus b squared minus c squared. Now let's see what happens here. C squared cancels with minus c squared. A squared cancels with a squared. B squared cancels with b squared then. So what we're going to be left with is a squared plus b squared plus c squared. Was that what I was asked to turn it into? Yes it is. So I can say is LHS equals RHS. Left hand side equals right hand side. Okay. Moving up. Onwards and upwards. Okay. Number 9 now, is it? Okay. With number 9, show that cos 180 minus theta equals minus cos theta. Well, if I go to my notes or my tables, okay. Does anybody have tables there?
Yeah.
Thank you. Okay, guys. So, Simon. Okay. Okay, guys. So, guys, it's cos 180 minus theta is cos A minus B. Okay, and cos A minus B is cos A cos B minus sin A sin B. Okay, by that logic it's going to be cos 180 cos theta minus sin 180 sin theta. Yeah. Now if I look up on page 13 of my tables, I'll find out that sine 180 is 0. If that's 0, it means the full thing doesn't exist anymore. I'll also find out that cos 180 is minus 1. So it's going to be 1 minus 1 cos theta, and that gets me basically minus cos theta. Did anybody get that out last night? Okay. Now, moving on, express cos A and cos B in terms of the labeled diagrams. Causes means it's a cosine rule, okay? So what we're going to do next is we're going to do the cosine rule for each one. Now, C is opposite the angle alpha. So it's going to be C squared equals, the other two sides added together, P squared plus D squared minus 2PD exactly, cos alpha. Alright, next one is cos B, and opposite cos B is small b. Okay, so we're going to say b squared equals d squared plus q squared minus 2qd cos b. Now in both of them they want me to get these ones on their own. So what we're going to do is we're going to move them both over to the left and move this one over to the right. So for the blue one, we'll cut it in half now, okay? So for the blue equation we get this 2bd cos alpha equals p squared plus d squared minus c squared. We're then going to get cos alpha equals p squared plus d squared minus c squared all over 2pd. Next one is the red one, 2qd cos beta equals d squared plus q squared minus b squared. Divide. So cos beta ends up to be equal to d squared plus q squared minus b squared all over 2qd. Okay, second one is done. Now, it says write alpha in terms of beta. Now this is actually going to be quite handy. This is actually the handiest question in it. Because they're both part of what type of angle? They're both part of a straight angle. So technically alpha plus beta is 180 degrees. And what it will mean is write alpha in terms of beta, bring the beta over to your side. Alpha equals 180 minus beta. Okay? And lads, links us back into the start. 100, so I'm going to expand this a little bit now, okay? It wouldn't have given me the start if I wasn't going to use it, so I'm just going to write down something underneath here. I've only figured this out now, first time doing this question. I reckon they're looking for me to do something like this. Cos alpha equals cos 180 minus beta. Therefore, cos alpha equals, what is this, guys? It's going to be minus cos beta, isn't it? Why is it minus cos beta? Because it says it here, we proved at the start. If you replace that with beta, it's the same thing. Okay? So, what I have now is, we now know that cos alpha is the same thing as minus cos beta. Minus cos beta is p squared plus d squared minus c squared over, oh sorry, that is confusing. It's p squared plus d squared minus c squared over 2bd. Now guys, these equations almost both are cos b at this stage. So Simon, if I change the left one and multiply both sides by minus 1, I'm going to get cos beta equals c squared minus p squared minus d squared all over 2pd. Now guys, now both equations equals cos b. You might ask, why did I do that? If you look in the answer, there's no sign of any causes or sines. They're all gone. That's why I knew I had to put cos beta equal to cos beta so I could get rid of the cosines and just leave the letters left over. Okay? So, what we're going to do is this. This equation here must now equal this equation here. Alright? And what happens next is 2qd. The 2 and the d on both sides cancels. And then what we have on the left is we're going to have to cross multiply up to p and cross multiply up to q. So what we're going to end up with is qc squared minus qp squared minus qd squared equals pd squared plus pq squared minus pb squared. Now, looking at both of these, I still don't really know what to do just yet. But what it wants me to do is, wants me to get pb squared and qc squared on one side. So pb squared and qc squared. qc squared is located here. pb squared is located here. I'm going to move that over one side. Anything else goes on the other side. So what I'm going to get now is this. qc squared plus pb squared, as the question asked me to do. And then I'm going to get pd squared, Now, how to group them up is a different matter. We can see that there's d squared. It's going to be a big quadratic by the looks of it. pd squared plus pq squared, pd squared, pq squared, then plus q, p squared, minus, plus qd squared. Now look at this, guys. This side is exactly the way we want it, isn't it? But the other side to the right isn't. So here's what we do. Take out p. P into d squared plus q squared. Okay? D squared plus q squared. And then we're going to get q into p squared plus d squared.
Should take an ID.
In the event you get stuck on something like this, a good idea is to multiply out what's here. When I multiply out what's there, I get this sequence of letters here. I'm going to match them up accordingly. I'm missing p squared q. P squared q is the full problem at the moment. Okay? So p squared q is meant to be here. So this is where my mistake occurred. It's not q squared p, it's p squared q. So that is where I would have made my mistake in the test. Okay? So now it's now p squared q, which is, let's check this out. So pd squared plus pq squared there.
That's right, it's just in the wrong order.
Oh, was it?
Yeah.
Ah.
QP.
So it's p squared q and qd squared. So I'm going to move the p squared q to here. I'm going to move the qd squared stays where it is. The pd squared goes here. And the pq squared goes there. Now I'm going to factorize it, okay? And let's see what happens this time. I'm going to take out p, and I'm going to get pq plus d squared. And then I'm going to take out what's common here. What's in common here is 1q. It's going to be a q into pq plus d squared. Now we can see that both brackets are exactly the same, and therefore it's going to be p plus q into pq plus d squared. That's it done. Okay?